If you look at the front of the microbit, you'll notice that it comes with a few built-in sensors. One is a three-dimensional accelerometer. One way we can use the accelerometer is as a tilt sensor. Specifically, the accelerometer can be used to detect if the microbit is being tilted along its x-axis, left and right, and y-axis, back and forward. For today's projects, we'll use the microbit to detect tilting along the x-axis only. All you need is a USB cable and the microbit. Use the USB cable to connect the microbit to your computer. Once your microbit is plugged into your computer, open Chrome and go to the following web address, makesense.co/p5jsduino. Then scroll down and under Sample Programs, look for the one that says Accelerometer Theremin Relative Coordinates, and click on the link underneath. This code tells your computer to play a sound, and you can change the note or frequency of this sound by tilting your microbit left and right. Before we click on Run Code, pick up your microbit and make sure that the side with two buttons is facing upwards. Now click on Run Code. Let's go through this code line by line so we can get a better understanding of what's happening. In lines 2 through 5, we create 5 different variables that will be used later in the code. Specifically in line 3, we create the variables x and y. These two variables will hold the horizontal and vertical positions of the blue circle that was moving across the screen. Now within the setup function, we tell the computer to create the canvas, the space seen down here, and then we set the initial values for x and y such that the circle will start at the middle of the screen. In lines 12 and 13, we create what's called an oscillator object and then enable it. This gives us the ability to control our computer's audio system and tell the computer to play a sound at a specific frequency. Then we get down to the draw function. In line 18, you're going to see a new function called accelerometer read. This function tells the computer to go to the microbit and go to one of the 3 accelerometers and take a reading. In this case, the 0 inside the parentheses means we want the computer to tell the microbit to get a reading from the x-axis accelerometer. That value is going to be a number between approximately -1040 and +1040. Whatever value is there, that will get stored in sensor value. Now, that value will be used in 2 different ways. First, it's going to be used to control how quickly the blue circle moves across the screen. In line 20, we're going to take whatever value is stored in sensor value and divide it by 300. So since sensor value ranges from approximately -1040 to +1040, when we divide that by 300, we get a value somewhere between -3.5 and +3.5. And that's going to be stored, that's going to be added to whatever the current value of x is. And so what this means is the circle is going to move that amount between frames. And so if you tilt your sensor a lot, sensor value is going to be a big number, which means x is going to change by a larger amount between frames, and so it's going to look like our blue circle is moving quickly. But if you tilt your sensor only a little bit, sensor value is going to be a smaller number, and so that means x is only going to change by a small amount between frames, so the blue circle will look like it's moving slowly. Eventually, or we have to check to see if eventually the circle moves off the screen. And if it does, we just tell the computer to restart the circle back in the middle of the screen. Then lines 24 to 36 just tell the computer to draw a gray background and then the blue circle at the location of X, Y. The other way we're going to use sensor value is to control the note being played by our computer. In line 28, we use the original value for sensor value, so a number between negative 1040 and positive 1040, and we add 1040 to that. That means we're going to get a number now between 0 and 2080. And that whatever value that is, that gets stored in the variable frequency. And then we use that value to set as a frequency for the note being played by the computer. So in line 29, we tell the computer to play a sound at that particular frequency. Now, because this is all taking place within the draw function, remember the draw function is like a loop. So this means we are continuously telling the computer to go get updated readings from the x-axis accelerometer. That also means then that we are going to update the value for frequency in real time. And we're also going to be changing how quickly the circle moves in real time as well.